In our previous class, we have discussed about magnets and magnetic substance and magnetic field. Do you remember what is magnetic field? Yes, it is the region around a magnet where its force can be experienced, right? And magnetic, as an introductory part of the lesson, I have explained all this about the magnets. Now, in your textbook, as an introductory part, you can see some pictures. The chapter starts with some pictures, isn't it? And here you can see in the picture you can see a fan is kept opened and motor is separated, and one is asking why there is large number of coils inside this fan. So the other is answering it is meant to increase the strength of the magnetic field. So what do you understand from this? Yes, some coils are given. There are some coils in the fan or motor, and these coils are meant to increase the strength of the magnet. So, can we increase the strength of a bar magnet also or natural magnet also? If not, is there any other kind of magnet in which we can increase the strength of this the magnet? Yes, that's what going to discuss in this chapter. Okay, and here second part, the picture is given here. Two similar kind of picture is given here. Same kind of picture, similar picture is given here. And here in this first figure, you can identify the poles, north and south pole. It is like a bar magnet. It is given as bar magnet. A bar magnet is given in the first picture. That I explained, bar magnet and different types of shaped magnet. In that bar magnet's picture is given here. Around that some lines are represented here, and the same kind of lines are here too. So what are they? That we are going to discuss now. Okay. So these all are, what are these lines? How can we draw these lines? What is the use of these lines? Properties of these lines, that we are going to discuss now. So children, you can see the board. I have drawn the same kind of picture here. Okay, so how can we draw this picture? That's what I am going to explain. How can we get such kind of lines around a bar magnet? That's what I am going to discuss now. You all know, might have seen a magnetic compass, right? It is a round box. Inside the box, a small needle is placed, isn't it? And that needle can deflect. So have you noticed, or have you allowed this magnetic needle free to move somewhere? Yes. Have you noticed what happened? It will align in the north-south direction of our earth, isn't it? If you keep or if you place a magnetic compass freely on the table and allowed to move, it will align in the north-south direction of the earth. And the end which points towards the north, it is north end, and the other end is south. And here, to draw the magnetic, these lines around a magnet, we will use a compass. Okay, so how to draw now? And here, before that I will tell you one more thing. And the magnetic needle inside the compass, the needle, that small needle inside the compass, that is magnetic needle itself is a small magnet. And as you know, that needle also has north pole and south pole. The arrow tip of the magnetic compass is the north pole, and the other tip is the south pole. So when we bring this magnetic needle near another bar magnet, what will happen? As I always know, magnetic needle has north pole and south pole. Bar magnet also has north and south pole. So when we bring another magnet near a bar magnet, what will happen? It will feel attractive or repulsive force as per the poles, which brings comes closer, isn't it? The same way, when we bring a magnetic compass near to a bar magnet, what happens? It deflects. Okay, it deflects. So let us bring a magnetic compass near the north pole of this magnet. Okay, so if I bring it here, so here the magnetic compass I brought here, kept it near to the north pole. So this needle arrowhead points towards the arrowhead will move away from the north pole, because arrowhead is the north pole. So light pole reflects, arrowhead moves away from the north pole, and so we got this point. And at that point we put a point here. And after that, putting the point, we remove this compass. It can be again, now we place the compass in front of the point which we noted here, and again needle get deflected and the arrowhead moves away from north pole. It shows this direction. Arrowhead shows this direction and put a point. And thus we get so many, we can mark many points like this around the magnet by placing the compass one after the other in front of the points, and then join all the points, we get a curve like this. And again compass place another position near the north pole. Again we can do the same activity repeat. We can get another line here and here also. So many lines around the magnet by placing the magnetic compass at different positions of the north pole. So these lines are called magnetic field lines, and this closeness of this magnetic field lines determines the strength of the magnetic field. So here you can see the north and near the north and south pole, the poles, the magnetic field lines are closer, and at the middle of the magnet you can see it is far apart. So the more closer means the strength of the magnetic field is greater. So at the poles of the magnet, the field lines are closer. The strength of magnetic field is more at the poles. And at the middle, as we move towards the middle of the magnet, strength decreases. And inside the magnet, you can see the lines are parallel. Outside the magnet, it is curved. So the magnetic field lines are closed curves. Magnetic field lines are closed curves. Outside the magnet, they are directed from north pole to south pole. And inside the magnet, they are straight lines parallel to each other. That shows inside the magnetic field is uniform. Or at any point inside the magnet, the magnetic strength of the magnetic field is same. And here also one of the important points to be noted is two magnetic lines never cross each other. So magnetic lines never cross each other. Okay. So these are the properties of magnetic field lines. So once again the properties I will explain. One, they are closed curves. Outside the magnet, the field lines directed from north pole to south pole, and inside the magnet, it is directed from south pole to north pole. And the magnetic field lines are more closer at the poles, and hence the strength of the magnet is greater at the poles. And inside the magnet, the field lines are straight lines parallel to each other. That shows the magnetic strength of magnetic field inside the magnet is uniform. So these are about magnetic field lines. And that's all for today, children. And in the next class, I'll be explaining more about field lines